All right, the purpose of this video is to demonstrate how to translate everyday language into syntax, everyday language into the syntax of propositional logic. What is syntax? Syntax is more or less the structure of our language. It is the structure of our language that would sort of be left over if we ripped out all of the content or the meaning of our language. The structure would be left, and that's the syntax. So we have a couple of examples here. If it rains, then the streets will be wet and the parade will be canceled. The structure of the sentence seems to be here. If R, then S and P. If it rains, then the streets will be wet and the parade will be canceled. The second example here. If either Dr. Heater is sick or it snows, then class will be canceled. And the structure seems to be here. H or S, then C. If Dr. Heater is sick or it snows, then class will be canceled. So that's just a couple of examples of the structure of our language, the syntax of our language. You might ask, why are we doing this? Why do we care about propositional logic? Why do we care about the syntax of our language? It's a fair question, and the answer is here. We care about this because we're going to end up using the syntax of our language to check the validity of our arguments, to check whether an argument is valid or invalid. So you might remember the definition of a valid argument. An argument is valid if and only if it follows a proper deductive form. In other words, if it really is a deductive argument. An argument is sound if and only if it is valid and has all true premises. Is this a valid argument? Suppose you're the lead investigator in some sort of robbery, right? You've come to the conclusion either Danny is the thief or Rusty is the thief. And you find out here on premise 2, Rusty is not the thief. Then it seems to follow that Danny is the thief. And the structure of this argument is thus, right? Either this is true or this is true. And we find out, oh, R is not true. So it must be that D is true. Now, this is a valid argument, and you can almost kind of see it, right? You can see that if D or R, and then you learn that it's not the case that R, then it must be the case that D. But we can't just rely on an eye test. We can't just rely on looking at arguments to be able to tell whether or not they are valid, primarily because they get much more complicated than this, or at least they can get more complicated than this. And there's literally an infinite number of valid argument forms. So we can't just rely on an eye test. We need to come up with a system to check whether or not arguments are valid or invalid. And our syntax language that we're going to look at, translating everyday language into syntax of propositional logic, is going to help us do that. It's going to allow us to do that. So the syntax language that we're going to have is going to have two types of sentences. Simple sentences, which are represented by capital letters A through Z, and complex sentences. We'll get to those in just a moment. Okay, so here is a simple sentence, just a sentence in everyday language. The Cardinals won the World Series. If I wanted to represent that in our syntax language, I would just use C. Straightforward enough. If I wanted to represent Batman will fight the Joker, I might just choose B, the capital letter B. It is worth pointing out, there's no rule about what letters we choose. For either of these, I could have chosen X or Q. What a lot of logicians or logic students like to do, however, is to pick out sort of a main term in the sentence, like Cardinals, and use the first letter to represent that sentence, C. Or Batman will fight the Joker, they choose B, because that's the first letter of one of the main terms, Batman. But you don't have to. If you wanted to represent either of these sentences with X or Q or Z or whatever, as long as it's a capital letter, you can do that. Okay, back to sort of our original slide here. We have simple sentences, but we also have complex sentences in our syntax language. Complex sentences are represented by simple sentences and at least one of 5 operators. So our complex sentences are made up of simple sentences, which we've already had, A through Z, and operators. We'll talk about those. So here's one operator, one of our 5 operators, conjunction. Conjunction is represented by the ampersand, the symbol that you've probably seen before here. It's picked out by the language and or but, and the parts of a conjunction are called the conjuncts. So if I wanted to represent the sentence, the Cardinals won and St. Louis celebrated, I might choose to represent that by C conjunction S, where C stands for the Cardinals won, S stands for St. Louis celebrated, and I put a conjunction of them. Those are the conjuncts, a conjunction of C and S. Brett is from California and he is a teacher, would be represented by B conjunction T. Right? B is a conjunct, T is a conjunct, B conjunction T. That represents Brett is from California and he is a teacher. Disjunction. Second symbol here, or second operator, is represented by the little v here, and that means either or. The parts of a disjunction are the disjuncts. And if I wanted to represent the sentence, either we will go to the park or we will go home, I might represent that by P disjunction H. P and H are the disjuncts, and I sort of put them together with the disjunction symbol here, the lowercase v or the caret. P disjunction H. The Cardinals will win or Josh will be sad. C conjunction J, where C stands for the Cardinals will win, J stands for Josh will be sad. Those are the disjuncts, and they are connected, so to speak, by the disjunction, the little caret, or the lowercase v here. Okay, third, conditional. Conditionals are represented by the little arrow here, as you see. They're picked out by the language if, then. The parts of a conditional are the antecedent and the consequent. The antecedent is what comes before the arrow, and the consequent is what comes after. So in this example, if it rains, then the streets will be wet. R, conditional W. R is the antecedent. W is the consequent. R, conditional W. If Lassie is a dog, then Lassie is a mammal. D, conditional M. In this example, D is the antecedent. M is the consequent. D, conditional M. Fourth, biconditional, our fourth operator. Our fourth operator is picked out by the double arrow here, and it is picked out by the language if and only if then. It's one thing to claim if X, then Y. It's another thing to claim if and only if X, then Y. The parts of a biconditional are called the components, and in this example, if and only if Lassie is a canine, then Lassie is a dog. C, biconditional D. C and D are the components. C represents Lassie as a canine. D represents Lassie as a dog. They're both the components. C, biconditional D. If and only if Lassie is a canine, then Lassie is a dog. If and only if I bring brownies, then I'll bring milk. B, biconditional M. B stands for I will bring brownies, or I bring brownies. M stands for I'll bring milk. They are the components. B and M are the components. B, biconditional M. And then lastly, the negation. A negation is just represented by a little dash. It is picked out by the language. It is not the case that, or not, or no. There's no real name for the parts of a negation. It's just the sentence being negated. If I wanted to represent the Vikings did not win the game, I might represent that by negation V. To say that the Vikings did not win the game is to say it is not the case that the Vikings won the game. So negation V. I am not a crook. Negation C. It is not the case that C. Negation C. To say I am not a crook is to say it is not the case that I am a crook. So negation C. Okay, and here are our 5 operators, all sort of put together. Conjunction, disjunction, conditional, biconditional, negation, the different symbols that they pick out, the language that represents all of those symbols, and then the names of the parts, conjuncts, disjuncts, antecedent, consequent, components. We do have to add one thing, parentheses. Suppose that I made the claim, if it rains, then the streets will be wet, and the parade will be canceled. And suppose you wanted to translate that into our symbolic notation. How would you do it? If it rains, then the streets will be wet and the parade will be canceled. What do you hear? There's an if-then in there. If, then. But there's also a conjunction. You hear and. So you're probably going to have a conditional and a conjunction. It might look something like this, right? If R, then C, then S and C. If R, then S and C. But that is actually ambiguous. This, without any parentheses, it's not actually clear what it means. There are a couple of different things of what it could mean, right? It could mean if R, then S and C, or it could mean if R, then S and C. What do you think is the right interpretation? What really is the structure of this sentence? It's this second one. It seems like what's being said is, look, if it rains, then the streets will be wet and the parade will be. This sentence up here would seem to mean, if it rains, then the streets will be wet, and independently of that, the parade will be canceled. That doesn't seem to be the right interpretation. So this seems to be the structure of the sentence, and we had to represent that with parentheses. Here's another example. If either Dr. Heater is sick or it snows, then class will be canceled. Right? There's a disjunction here. There's a conditional. But where do the parentheses go? Again, without parentheses, this is ambiguous. You have to add parentheses to really make it clear what it means. And it seems like the parentheses go over the H and the S, over the disjunction. If H is true or S is true, then C is true. If Dr. Heater is sick or it snows, then class will be canceled. That seems to be the structure of the sentence, and it's not this. Okay, so you have to add parentheses to some of your complex sentences. Here are some things to keep in mind. One thing to keep in mind, it's important. Every capital letter has to represent its own sentence. So if we have the sentence, if the Cardinals win, then St. Louis will celebrate. C does not stand for Cardinals. S does not stand for St. Louis. C stands for the Cardinals will win. S stands for St. Louis will celebrate. So every capital letter has to represent its own sentence. Here's another thing to keep in mind. You can't use the same letter more than once unless the exact same sentence is used, and then you have to use the same letter again. So if I wanted to say, here's the claim, if Jerry is from New York City, then Jerry is from New York State. I can't represent that by J, conditional J, because in the first instance, that means that represents Jerry is from New York City. And so you can't use that same letter to represent this claim, Jerry is from New York State. That is technically a different claim. So you have to use something else. You have to use something else like if J, then N, or J, conditional N, where J represents Jerry is from New York City, N represents Jerry is from New York State. But contrast that with this example. Either God exists or God does not exist. To say either God exists or God does not exist, maybe you're having some sort of theological discussion, is essentially to say, right, either God exists or it is not the case that God exists. So G is really represented twice here. And so you wouldn't want to use a separate sentence because this means the same thing in both instances. Either God exists or God does not exist. You do have to use the same letter again because the sentence comes up again. So that's another thing to keep in mind. When you're translating, two capital letters or simple sentences can never be quote unquote next to each other. So if X, then YZ, that makes no sense. PQ or S, that makes no sense. Two simple sentences can never be together or touching. The only time two operators can be next to each other is when one of them is a negation and it comes second. So if I wanted to represent if P, then not Q, I could do it this way. That makes perfect sense. This is well formed. But P, conjunction, biconditional Q, this makes no sense. This is meaningless. So again, the only time two operators can be next to each other is when one of them is a negation and it has to come second. Another thing to keep in mind is that whatever language comes first, the corresponding operator goes on the outside of the parentheses. So if I were to say something like, it is not the case that if, blah, 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 it is not the case that comes before the if. So the negation is really negating the whole thing, and the negation comes on the outside of the parentheses. The negation is saying that the conditional is false. But if I said, if it is not the case that would look something more like this. It is not the case, right? If it is not the case that the if goes on the conditional goes on the outside of the parentheses, and you really don't need parentheses at all. When do you need parentheses? Typically, whenever you have more than one operator. Whenever you have more than one operator, with some exceptions, when there's negations involved, it's actually ambiguous what you would be saying if you don't add parentheses. This is ambiguous. If you said if R, then S and P, that means nothing without parentheses. You could mean, again, either R, if R, then S and P, or it could mean if R, then S and P. So you would need parentheses depending on the meaning of the sentence. So you would need parentheses here. And this is probably the right way to do it, as we mentioned before. Right? If R, then S and P. But for example, like this, you wouldn't need parentheses because this is not ambiguous. You can tell what this means without adding parentheses. If D, then not C. Right? It's not ambiguous what that means. Okay, here are some practice problems for you to try. If you want, you can pause the video before I move on and show you the answers with a brief explanation. So you can do that now if you'd like. And there are the answers. Bill is from Boston. That's just a simple sentence. Bill is not from Boston. That's just the same thing as saying it is not the case that Bill is from Boston. If Bill is from Boston, then Bill is not from Springfield. B, conditional, negation S. Either Bill is from Boston or Bill is not from Boston. B, disjunction, negation B. And then it is not the case that Bill is not from Boston. Yes, you need negation, negation B. Negation, negation B. Here are a handful of more practice problems. If you'd like, you can pause the video before I move on. And those are the answers. If Han saves the princess, then he will get a reward and he can pay off Jabba the Hutt. A slightly nerdy Star Wars example for all of us. If H, then R and P. Today in my logic class, I learned the interesting fact that the College World Series is played every year in Omaha, Nebraska. That's just a simple sentence, right? There's no ifs then, there's no disjunction, there's no conjunction, there's no and, anything like that. So it's a big, long, complicated sentence, but it's just a simple sentence. 8, if you work really hard and you have a little luck, then you can be successful in whatever you do. W, conjunction L, then C, right? The sentence is saying that if you have these two things, you'll have this third thing. If and only if Garfield is a cat, then Garfield is a feline. This is pretty straightforward, just biconditional. Just as a reminder, right, G doesn't stand for Garfield, F doesn't stand for feline. G stands for Garfield is a cat, F stands for Garfield is a feline. Whenever you have a capital letter, that has to represent its own simple sentence. 10 through 13 here. If you want to pause the video before we move on to the answers. Either logic class is not canceled or I will cry. Negation L or C. A hot dog is not a sandwich. That famous debate. Negation H. The test is Friday, and if you do not pass the test, then you will not pass the class. F, and if negation T, then negation C. Really look here for these examples, 12 and 13, because they are kind of complicated. Look and see if you can really sort of see the structure in the sentence itself. If you can sort of understand why this is the correct interpretation, why this is the correct interpretation for 12. In 13, it's long and complicated, but as you see, these simple sentences are repeated, so we have to use the same letter again. few more examples here for you to try out. And the answers. If we want to look at 15 here, it is not the case that if Josh is from Kansas City, then Josh is not from Missouri. Negation K, then negation M. And a few more examples here. Again, 18. So it's a long-ish sentence. The instructor of my logic class, Dr. Joshua Heater, informed me that he grew up in St. Louis, Missouri. That's just I. That's just a simple sentence. 19 is a little bit more complicated. See if you can sort of peer in and see why that's the correct structure. But this concludes the video for translating everyday language into the syntax of propositional logic. This is the type of thing that you have to kind of do with repetition. So if you do have to go watch the video again or watch parts of it again, you would not be the first one to have to do that. Learning logic is the type of thing that does take a lot of practice. So if you have to do it a few different times, you have to repeat over and over, you're not alone. So give it a shot if you need to do it.